So good afternoon. My name is Jay, and I'm the reporter. So Holger was leading the session, and it's about benchmarking and tumors. And we had a very active discussion for about an hour, and hopefully we can share with you some of the discussions that we had and some of the conflicts that we also could face through this approach. So benchmarking is probably one of the key fundamental procedures that we have to overcome. And it's not a straightforward method because there's multiple angles and parameters that we have to take into consideration. So for example, sample preparation is one of the many steps that we have to consider. We are also part of the tumor preparation, so we'll talk a little bit about that. Of course, there's a benchmarking of technology is also very important, and which platforms to utilize and how to set standards for that. We briefly talked about spatial technologies and how to benchmark that, and also, of course, which data analysis tools that we should employ, and that could significantly will depend on the biological question and which platform that we're using. I think it's, although this diagram doesn't really illustrate it, but as you all know, that this whole process is linear. So we all go through sample preparation first, and then we generate the data through a certain technological platform, and then we perform the data analysis. And you can imagine that if the sample preparation is done improperly from the beginning, it will just significantly amplify the error that will incur over the time of the whole procedure. So we truly believe that having the sample preparation done correctly in the very beginning is probably the most fundamentally important step, and setting good standards and benchmark is probably is what we want to aim for. So Holger went through several examples of multiple numerous attempts that are being made around the world to create and curate different methods and set benchmarks. So I won't go into every single detail here, but I think this slide will be on YouTube, so you can always go back and check these references. But I think it's really important to note that there are many efforts that are ongoing, and I think they do deserve a lot of attention. I think benchmark really is an art. I think this kind of highlights that all of us are quite busy, and we want to generate our data as fast as possible, and we're all very busy, and there's somebody else come in and say, why don't you try this, or you should do this and that, and we all ignore sometimes most critical impact of what we need to do. Okay. And I think this is something that we really have to take into consideration and listen to the community. And I think we need to come up with good standards and guidelines to guarantee biological and meaningful data, because that really creates value. But we also have to stay flexible in a way that we don't set too many regulations and too much burden on the community that they feel demotivated by all these rules and guidelines that are set forth by the community. So I think this balancing act of how to generate really truly valuable data to the scientific community is the key, and that probably is the art of benchmarking. So the first topic that we really want to highlight and emphasize is sample preparation. And sample can also mean tumor. And we all know that there's an artifact, there's a preparation artifact, is inevitable. There's no way to overcome this. So one of the ways that we can do our best to minimize this variation, to optimize the highest quality, is really have thorough recording of metadata, and ORIT thankfully was there and provided really good suggestions. And these are actually written in the Google Doc, and you're more than welcome to access this Google Doc for detailed recommendations of which items should be recorded. I think it went from the time that it takes to prepare the samples, and any error that occur throughout the process are carefully written. And I think the true value can really come once the community here as a whole decides to hone into a well-standardized protocol, because then the data that we will generate will truly be synchronized as much as possible. So I think having a standard SOPs, so standard operating protocols, would truly be valuable, and I think that we can benefit very much. But of course, you could ask the question, what is the standard to establish the standard operation protocol? Because how do you know if your SOP truly detects all the cell types that you're looking for? So there's a bit of a catch-22 that you're trying to establish the ground truth without really knowing what the ground truth is, especially when it comes to rare cell types. It's very difficult to know if the protocol is really picking that up or not. So I think there needs to be a continual and reiterative approach to constantly improve with flexibility. So I already mentioned what is the ground truth. It's difficult to answer that. I think there are several ways to do this. I think tissue dissociation protocols can vary from cell type to cell type, and performing nuclear RNA-seq may minimize potential variations that are occurred through tissue preparation, and that having nuclear RNA-seq across all tissue cell types to have a general reference was recommended. There was also suggestions to create matching tissue in bulk and perform RNA sequencing. And I think there's an added benefit to do this because you can later deconvolute for understand prognosis or the conditions of tumor. I think that was highlighted during the single cell meeting at the TCGA, how you can use TCGA data to infer the diagnosis and prognosis information that was originally derived from single cell data. I think there was also a huge interest to archive the tissues and perform imaging, at least histology of the sections, so that can be utilized as a reference. I think a pathologist would really appreciate and will be able to assist in classification of cell types and what you would actually expect to see in your RNA sequencing data. And of course, potentially using spatial transcriptomics to, again, correlate the information that you get from the suspension method to the spatial method, which was talked about just now. So second part is technology platform. And I think coming up with a good benchmark to evaluate different technology sequencing platforms is critical. And this workflow is actually an ongoing workflow that's led by Holger. And basically, it is an approach to generate a pool mixture of cells. So here you have mouse colon cells from 11 individuals. You also have peripheral blood mononuclear cells of humans, and also cell lines. And he has generated 100 vials of these, and already have disseminated to 14 laboratories to perform various RNA sequencing protocols. So the goal there is to then sequence to a similar level of depth and perform demultiplexing. And the idea is to go through several rounds of deconvolution so you can detect doublet rates, because here you have the mouse and human samples. You also have different donors and different tissues. So the idea is to help to identify cell types with accuracy, because we know the proportions of what we expect, cell state definitions, molecular capture, doublet rate, as I mentioned, batch effects, and reproducibility. So hopefully that can generate a very comprehensive reference for the benchmark data set. So in the future, if anyone is coming up or suggesting new protocols for RNA sequencing, you can ask Holger for this vial and readily compare your data to this reference data set, and it will be really valuable to this framework and this community. So I think the one caveat that we should mention is that common platform is great for standardization, and I think already we've seen a dominant form of platform being presented through a couple of days here. But we also have to be mindful and be open and flexible, because some of these can be skewed by power users, and we want really the best data. But again, that really requires time of thorough evaluation, and we're really needs to be careful with what we are aiming to achieve. I think you can go through phases. There are phases of breadth versus depth, and I think we need to be mindful of the new technologies that are on the horizon as well. So the goal should be that as scientists, these decisions that we make, the recommendations that we make to the users should be data-driven, so it's less biased, and that it really provides the most rich and valuable information in the end. Provide decision trees per different biological questions, because depending on the question that you're asking, you may require different platforms. And to detect rare cell types, there are suggestions to use simulations or spike-ins, and also perform single molecule FISH or immunohistochemistry for validations of cell types that you're detecting or the genes that you're detecting. And just reiterate this to confirm the platform that you're using is robust. I won't have time much to go to the data analysis benchmarking, but this just highlights one example, which was presented in the poster during the single cell biology meeting. Basically, this are a list of all the trajectory pseudo-timing analysis tools, and have suggest various guidelines on how to apply them. And there are some strengths and weaknesses to each platform, and that would really can lead to how you interpret your biological results. So I think having a thorough investigation to different analytical tools are of great importance as well. So I just mentioned that. I think there was some discussion about what is the optimal benchmark data set to develop computational tools. Just mentioned pre-mixed cells, but there are other model organisms potentially could be used that has really well-defined cell types as a model to create benchmark data sets. So I would just want to end with some follow-up items or what we can actually do from now on. I think we realize that it's extremely important to establish an experimental design work group. I know there are a lot of work groups already, but I think this is probably very critical because, again, it is the very first step of all the procedures that we have to go through. There's already a work group for computational analysis, work group for technology standardization. Hopefully, correct me if I'm wrong, but maybe there's not yet a work group for sample preparation or how to coordinate these different SOPs that are being published in Protocol IO, and who makes the call to say, okay, everyone use this protocol, but not this protocol, and this decision body needs to be established. So at the same time, once it is established, we should work very closely with existing work groups such as the analysis and technology, also with the DCP governing group to provide the correct and necessary meta information that would allow us to set standards. So there is a Slack channel, so please join us. There's it's very easy, #benchmark. And I think your inputs and your experience especially will be extremely valuable to improve the standards. So with that, I just want to thank you and take questions. Or comments.
Thanks, Jay. Questions and comments?
I think it's really important. This goes to the very first point that was said about the nuclei across all the tissues, and I am clearly the last person who has anything against nuclei, right? But I think what we've learned about all methods, and it doesn't matter how long they've been around or how new they are, is that they all are, none of them is perfect, everything has biases, and the best way of kind of triangulating the truth is having a multiplicity of them. Yeah. And I emphasize that because we don't really know, right? Are we losing something in this method, or losing something in that method? And that's true also for the in situ methods that I love dearly, just so it's clear, and for the cell dissociation method and the nuclei. Somebody, when we were in the imaging session, somebody reminded that most of the prep damages the extracellular matrix, and that it's very hard to maintain the extracellular matrix well. And that's why I think it's really important for all of us not to consider anything as a single gold standard that holds all truths, but to appreciate the fact that having a multiplicity of methodologies each of them applied broadly lets us see all of their relative, I don't want to call it faults, but limitations, and as a result get to an answer that actually is much closer to
Absolutely.
a comprehensive view.
Yeah, I like that. And kind of more data-driven approach to, yeah.
Yeah, I was going to actually zero on the exact same point, that if anything can really validate the nuclear prep and get the closest to an unbiased distribution of all the cell types, that just an XY correlation analysis of bulk versus the average nuclear prep. Let's just see how close that really is, and then how close to that acts as what are the biases that are present in that as a function of prep technology, prep method, sample prep method, and then iterating through the different wholesale release protocols. Where are the biases in that as a function of sample type and method?
Yeah.
Really like that.
Yeah. So although this is not using real human tissue samples, this comprehensive comparison also includes nuclear RNA-seq along with other existing protocols. So hopefully that can give us some ideas as well. But yeah.
Question about the first point on the final slide, this common, coordinate this SOPs. I'm just wondering how realistic is that across different hospital settings and different systems, different countries? Are there any exemplars from other fields that we can look toward to actually build that? Because it does have such a profound effect
Absolutely.
on the data acquired from the tissue.
Yeah. And not to mention the lab effects and the person who's the operation. So I think, as Orit has suggested during the meeting, every lab probably needs to make slight modifications to each protocol that fits the standards within each country. But I think as a community, we should at least provide some standard, at least bare minimum of what needs to be done and what are the QC metrics that will help us to say this is passed, this is not good enough for follow-up validations and data production. So I think these kind of standards should be recorded. So for example, if samples were sitting around for 45 minutes or longer, we will not treat these samples for data production. So but what about 40 minutes or about 30 minutes? So it's kind of, it is not trivial, and I think having that working group to standardize this would really help.
Great, thanks, Jay. So we will move on.